All right, so let me talk about myself a little bit first. People always ask me, like, why are you talking about this? Where do you come from? And the story I'd like to tell you is this is my 20th year in InfoSec, so I've been doing it for quite a while, and I've seen quite a bit of stuff. Always enjoy telling stories about my past, and I try to blend in the fact that big data has actually been around for quite a while. So I work now at EMC, and I'm in a group called Trusted IT, or Trust. And we basically break the organization into three categories. So we have big data, we have cloud, and we have trusts. And it's seen as the future, essentially, of IT. So obviously, you're going to be using big data. You're going to be running it on the cloud. And why would you use either one of those unless you trusted it? So my role is really to help people understand why trust cloud. And to that end, I wrote a book 2 years ago called Securing the Virtual Environment. And I'm working on a book right now called Securing Big Data. If you can see in the little red bar above that, it says the realities of securing big data. Because when I wrote the virtualization book, I wrote it to be hands-on, and it comes with a DVD. I wrote it with another guy. We were working at VMware together. I was a contractor, and we were basically penning what we had experienced over a number of years. I really started in '99 with virtualization and even servers back then. We were pushing them over X Windows. And so by the time we wrote this book in 2012, it was like answering the questions people always ask. Is the hypervisor safe? So when I switched to writing the big data security book, I did not find the same sort of realities. What I found was something completely different, which was you can't actually secure big data in the way that I had confidence in virtualization. I did not in big data. So I dug deep, and the book now is close to final, but it's about the things we need to work on. And so the point of this presentation, really, based on my own experience and history in this field, is that we really have to come together quickly because there's an opportunity for security to work in big data, and right now it's just being developed without a lot of best practices or without lessons. So we're making mistakes like reinventing the wheel, and that will be a bad thing, as you'll see today. So one last note here. My background really before I got into IT 20 years ago and focused on security was in history, political science, philosophy, and anthropology. So you may find a lot of that tied into the presentation today. So let's talk about three things today. First, risk context. Second, I'll talk about knowledge and how knowledge is changing fundamentally in the big data environment. What we think about as important, what companies want is going to change. And then finally, the controls, the sort of meat of the presentation and how hard it is to secure this environment. So first, risk context. So who here plays Risk, the board game? Any hands here? Some people know what the board game is about, right? So the idea is you follow these rules and you get to take over the world. But as we probably all know, nobody really follows the rules in Risk. And even in human life, we don't follow the rules. Yet in the study of security, generally when we're talking computer science, math, we talk about statistics, we look at big data as a bunch of nodes that are supposed to behave. If you look at it from the spectrum of anthropology, for example, you find the opposite. You go into an environment and you expect it to not meet any of your expectations. You expect it to be something different that you have to understand, build a knowledge or a taxonomy about it. And so what we find is something more like this. There's simple theoretical levels of understanding, and then there's complex and real levels of understanding if we're trying to map risk. So let's take an example. If you're playing chess and you're playing against the computer, there's a good chance that that computer is going to be really, really successful. So Watson, for example, is very successful. And the power of Watson now is coming down to the desktop. But if you play the game Go, how many people play Go? How many people have heard of the game Go? Okay, so the idea is it's a 19 by 19 square board, and you basically put down pieces and try to take over the landscape, right? So you try to conquer territory in the same way that Risk is played. But computers fail miserably at Go. And why is that? It's because the success of Go has something to do with this sort of surreal, it's almost like this subconscious level of talent. So the ability of the computer breaks down, even though it's a race, right? So if you look at chess, after the first move, there are 400 possibilities. When you play Go, there are 130,000 possibilities. So you would just think if you speed up the computer, it would get better and better, but that's not been the case so far. So what we're finding instead is that in complex, guerrilla-based, human-based, behavior-based environments, which is more what big data is about, we're finding, it's going to be a different form of risk that we have to deal with. So one last example here. Anybody know the Brown M&M story from Van Halen? Does that ring a bell with anybody? So does anybody know who Van Halen is? So rock star? All right. I'll sing a few bars. Maybe I'll bring back. No, actually, he's famous for putting this little note in his rider. So when people would set up his concerts, he would have this little thing in it that said, make sure that my dressing room only has brown M&Ms. And it's like game theory, because at the end of the day, he would go to his dressing room before the concert, and he would look, and if he saw brown M&Ms, he knew the people that set up his concert had followed the letter of the requirements, and he didn't have to worry about it. But if he saw other colors, he knew immediately that he was playing with somebody who wasn't going by the rules, and it was going to be much more difficult. He could expect failure, essentially, of the set or things not to show up. So the way that you play the game is basically different than if you just play by the rules. And with that as a note, also think about how people are constantly trying to evade knowledge. So this just came out, right? This guy wrote a modification to CyanogenMod, which allows you to create fake data on your phone. So all the forensics tools are looking for your contact list, for example. It detects the forensics tools, and it feeds it a fake list, or it feeds it fake text messages, right? So this is the world we're living in. And in the big data scale, you're talking about hundreds of thousands of nodes, or millions of users. I worked at Yahoo. I was in charge of the group that we did security for mobiles, and we had 20 million, 40 million phones that we had to deal with. So these are the sorts of issues at scale that get very different very quickly to what we deal with in a 1x2 or 2 basis. Sometimes, we would talk about things and say, how are you going to fix this problem? And you'd say, well, let's do it this way. And they'd say, that would work for 1,000 systems, maybe 10,000 systems, but we have 1 billion systems. How are we going to fix it now? So let's look at stoplights, for example. I talk about this all the time, and so I really don't believe in stoplights, which leads to some very interesting discussions with policemen. And in fact, I had an incident the other day at a stop sign. Pulled me over, lectured me, said he was going to give me a ticket. I was like, I'd be happy to take the ticket. He just wanted to lecture me, and then he drove off. But I had a good discussion about why I don't believe they should exist. And it's basically that the stoplight was developed around the ship analogy. So red and green are go and stop in shipping. But the ships are in sort of this open water space, and they move constantly, sort of like a roundabout. So as you come towards each other, you negotiate and you move on. There's no stop and sit and wait when there's no traffic. You ever do this? You ever stop at a stop sign and look around and think, this is the dumbest light ever. There's no traffic here. It's the middle of the night. I should just go. But I don't want to go because I'll get a ticket. But I should go. That's you being smarter than the light. The light is really, really stupid. And so we've built this model to protect cars, keeps all the pedestrians off the roads, keeps the bicycles off the roads, and it's completely biased. What we should have done is built cars like we built airplanes, which is like air traffic control. So as cars are getting close to each other, they say, oh, I'm going to have a collision, so I'll just move around, kind of like yield, the way ships originally did with green and red, right, starboard and port. So the basis of knowledge for these stoplights is so simplistic and designed around these cars, we're wasting tons of fuel. There are all sorts of studies about how to get rid of them now. And in fact, we're moving towards game theory in stoplights, where they can detect each other and say, there's a bunch of cars coming, so why don't you turn green, but there's no traffic this way, so you should turn red. And cars can communicate with the lights. Fire engines, for example, can turn them different colors. All right, so I could go on forever in some of these examples, but let me move quickly into, like I said, I studied philosophy originally. So anybody know who David Hume is? So David Hume is like an amazing philosopher. I think he's probably one of the best philosophers ever. And he doesn't get a lot of airtime, unfortunately. Rousseau, on the other hand, got a lot of airtime. Everybody knows about Rousseau. He had all the ladies. But Hume was like this Scottish guy who came up with these amazing theories about, I think one of my favorite examples is the doorknob. So you never know how to turn the next doorknob. Right? The basis of knowledge is that you would be able to go up, look at the doorknob, open it, and go through the door. But just the other day, I was in a restaurant, and these guys wanted to go to the bathroom. And so the first guy went up, and he turned the knob, didn't turn. And so he stood there, and then he gave up, and he walked away. Next guy went up, turned the knob. Same thing. He was like, somebody must be in there, walked away. Third guy came up, and I said, pull the door. Just try pulling the door. So he pulls the door, it's open. Right? So they kept thinking like this doorknob's going to have to turn. If it doesn't turn, it's locked. And this is the basis of Hume's philosophy, that all of the accumulated knowledge is the evidence that we use to sort of decide how we're going to deal with risk. But it's not perfect. We can't predict perfectly. We just go anyway into environments that are risky because we use our evidence to figure out the best path forward. So that's sort of the actionable insight piece of big data. And in this sense, when you get into a big data environment, you start to see people give lectures and talks about how they're going to identify the good and the bad. So spam, for example, or on mobile devices looking for viruses, or even on computers, right, antivirus. So here's an example of how you might tell the difference between good and bad. You can look at the identity of the user, you can look at the location of the device, you can look at whether it's going to spawn a process when it opens a PDF, suddenly another process starts. So all these things you look at. And then if that's the good identification, then of course you can look at the bad and it does the exact same thing. And so this is one of the problems we're having. So let me dig in a little bit, just for an example. It would be like me, making this connection to some device, right? So these are the sorts of data sets that we're building. And if you build it bigger, bigger, and bigger until you get as much data as possible, you're basically taking all that information, breaking it down into a taxonomy, and then giving it a risk score. So you can sort of figure out who you should and shouldn't trust sort of quickly. And it looks something like this. I really do research for defense in two ways. One is accumulation of knowledge, so I can tell you're a threat and I should stop you. And the other is, once I know you're a threat, figuring out how to get away from you. So it's like boxing. I see the fist coming and I dodge. But I also know that I'm supposed to hit you and not the referee. So you're constantly accumulating this knowledge, you're constantly looking for ways to avoid. And because I work with virtualization, it's become more and more cool the way that you can make systems move very quickly. We can move an entire data center over 200 kilometers in real time with nobody noticing, which also means that you can steal a data center over 200 kilometers without anybody noticing. So the technology is moving very quickly in some interesting ways. And so with all of this great technology, we get this big data market, which I've interpreted here slightly, but it's basically you have infrastructure, you have analytics, you have applications in every industry, and then it's sitting on top of an open source software basis, and then that's sitting on top of these data sources that are coming from everywhere. So you're getting it from existing markets, you're getting it from your Yahoo, you're from your Google, this user services, you're getting it from the Internet of Things, which is becoming more and more contemporary. People want to talk about the wristwatches that talk to things and their heaters and their thermostats. And so there's also research institutes that are like hospitals that are generating. So all this data is flowing up into this huge market, and this is the point of the talk. We're getting a giant market of some really cool insights for action. So we're centralizing data into places that we can do cool things with it, and we're supposed to make knowledge out of it. And we're using all these terms, which historically, change. So you can call it data archaeology, you can call it machine learning, but it's all essentially the same thing. It's that we're trying to get to this period of knowledge. All right, so we've covered risk and how risk is changing. Now let's talk about how knowledge is changing. My favorite part of the presentation, because I get to tell a story, actually two stories. Anybody recognize what this is? Jaws, right. So there are two stories here. One is that you're the shark, and that fishing boat is going to try to kill you, like every fish in the ocean. And the other is that you're the boat, and there's a shark trying to kill you. So let's talk about the boat first. The shark's coming after you. What are you going to do about it? So finding threats inside the data, like looking at the ocean and trying to figure out where Jaws is and get away from Jaws or kill Jaws, is becoming an exercise in digging through data like this. It's 500 petabytes per month by 2016 is what customers of ours are starting to talk about. And so we're building, each rack has basically half a petabyte. Sometimes we can do a petabyte. So 500 petabytes a month is a lot of racks. So we have to get density down, right? So these are the movements in the industry. You're looking for sharks in that data. And so this is a real example of how people are mapping lions and leopards and hyenas in areas to try to figure out where the predators are, where the prey are, and how you can stop them. But let's look at this in terms of technology. So here's our shark coming into our environment, and it's going to go onto our web page, and it's going to do transactions, just like anybody who's in the bank. So you might go to your home page and then go to the bill pay and then submit and then leave. And over time, you build a pattern, right? You have a particular way of walking through the website. Now, the shark that comes in is going to go something slightly different, like make a lot of transactions really quickly, or move money to Russia, or do something that's suspicious for some reason. So that's how you can look at the velocity of the transactions, the order that they're in, right, where they're coming from. And so you get this sort of map. Visualization is one of the coolest parts of big data. So you get this quick visualization. This is the eye candy that everybody wants their big data to do. Suddenly there are 3 red dots. Wow, okay, sign me up. I want to get into this so I can find the sharks. So here's some quick examples. You can see here in Poland that the percent of voter turnout for and votes for the winner was very low. So basically no one in Poland voted and no one voted for the winner. That's kind of what this says. Whereas you can see over here in Russia, people are up in the right-hand corner. So there's a strange, the red circle shows you there's some strange outliers. So those would be your sharks, basically, voting 100% for the winner and really high turnout. So here's some more examples. This is where NASA, they're giving up this data for free. Anybody can download this data to look at all kinds of things around the world. So you can look at typhoon behavior in the past. You can go back and map typhoons with your models and see if they actually ended up where they did in real life. So you can actually test the accuracy of your own machine learning algorithms. You can see, according to this, that there's a spread of invasive species, which to me is like saying you can look for aliens, right? You're coming into your environment. So here's flooding in London and England, and here's flooding in Colorado in the upper left-hand corner. So this is real time. You could see very quickly like whether you're going to get flooded or blocked. Those little red circles are places in Colorado that you couldn't drive through. This is a fire in California where you can see the forest for the trees. So on the left are the trees burning, but on the right, this is NASA basically giving real-time analysis of each tree burning in hotspots, so you can see as it's growing how big it's going to get and who's going to be in the line of fire. So I could go on and on with this. There's so many cool examples. This is lightning yesterday in Poland, actually. How many people knew there was lightning in Poland yesterday? Well, it was a real-time map. Right? You might have heard the thunder. So you have this real-time experience yourself, but you might ask, well, what's really going on? So they're mapping this on Blitzortung, right? Blitz means lightning. The more famous use of the word blitz, at least for me, I always think of the Blitzkrieg. So here's a map of where you're safe in London during the German bombings. Basically, they covered the entire city. On the left, here's the experience of the actual person. On the right is where you're safe. So here's an example similar to that where it's safe to walk in Minneapolis. This shows you all of the places pedestrians are being killed. So you can see knowledge is becoming very, very important and powerful because you can quickly say, put police on a corner or get rid of those bad drivers. I mapped some of the people using phones. Here we're looking at Android, iPhone, and BlackBerry users in San Francisco. And I could see, I don't know if you can see here on the screen, it might be a little hard to read, but there's a path here, there's a green path, and that basically shows that the Android users are on ferries and they're going to Alameda, whereas the Apple users, besides the iPhone users, besides taking over the city, are basically going across the bridge, so driving, or they're actually in the water. Well, they could be swimming, but it's more likely they're on boats. Here's a better example of that. So I just did BlackBerry, and I wanted to see, where are the BlackBerry users in the city? And, oh, see, this is going to be off the screen, isn't it? Bad resolution. Well, you might see it on the side screen. But basically, over here, there's a concentration of green. Can you see that? So the BlackBerry users are either centering around, hovering in to kill the Apple users, or Apple has very smartly and strategically placed their store right in the middle of where people are coming with BlackBerries. So you can see how knowledge can be pretty powerful stuff. Just for reference, a good way to test your knowledge is to look up here. This is also a touristy area. So I think what we're seeing is that the people with BlackBerries are tourists coming from other places, and they're hovering around areas that tourists always go. In fact, this is a path that tourists often take. So Apple put their store right in the center of the heart of tourism. Very smart. Sell those people, and tourists buy a lot of Apple products. So here's San Francisco and Beijing compared, not really directly, but the idea is in Beijing you can see this crazy line of commute times, so you might want to fix that, right? And in San Francisco, this is mapping out the amount of time you waste per day versus other cities in the country. So it's basically saying when to drive, how fast to drive, where to drive. This is an interesting one that basically shows that drones have this problem where they're banned from airspace. Drones are a threat to airplanes, right? If you put one up, you can cause a helicopter to crash or a plane to crash. So they've been banned, and this drone company has created no waypoint zones. So 5-mile radii of major airports are blocked in the software. So this is how they're basically showing how you would be blocked if you flew this drone with this. This is software that allows your drone to be programmed with a GPS. So you can put in 100 waypoints and send it off, which you can't see. So it cleverly just looks and says, oh, I can't go in there, and builds waypoints around the no-fly zones, right? So obviously, in a security standpoint, you'd be like, how do I fix that so it actually goes in the no waypoint zones? How can I corrupt that data set? Maybe that's just the way I think. I'm constantly trying to figure out ways to knock drones out of the sky. So reducing global risks on a real scale is like taking a map of all of the air routes, 60,000 routes in the world, and looking at the data and finding out that if you reduce the amount of paper that each pilot carries on him or her, so they have these boxes they used to carry, I don't know if you remember seeing those, but they have all the instructions. So they switched over to iPads and to Androids, and so by moving to tablets, they save 400,000 gallons a year. So that's one airline reporting that. So it's doing data analysis to figure out ways to make the airline safer, cheaper, better, faster, things like that. And in fact, the airline that we lost, apparently, I haven't kept up with it lately, but I read that they weren't doing data analysis because they didn't have the data because the airline chose not to pay for one of the data feeds that they could have had. So in the Atlantic, it would have been required to have the data feeds, but in Asia, they didn't have that feed. So obviously generating a lot of data, a lot of interesting analysis. Delta, the CEO, actually said, we have massive amounts of data, we know who you are, so I conveniently changed their logo for them. I thought this was a little more appropriate. But basically what he's saying is, we can track you so we can give you better service. All right, so looking for sharks, that's how you find them. You can see the analysis, the knowledge that comes from it. But let's flip around to the other side now, right? What if people are coming after us? What if we're the shark and we're trying to get rid of these boats that are dipping in and killing all of the fish, right? They're not supposed to be even in these waters. So, for example, anybody know who this guy is up in the right corner? Any guesses? Coast Guard, yes. Which country? No. China. Yeah, that's China chasing the Koreans out of their waters. So, not to make any point here, it's just everybody's chasing everyone else out of everyone's waters. So, like if you go to Somalia is a good example. They got rid of the government there. So everybody was poaching in Somalia. Every boat in the world would go to Somalia and steal all their fish because no one could stop them. And then people had to go and like enforce the international fishing laws. Sea shepherds and people like that go after them, these international consortiums. So the idea is the data lake, as an analogy, is actually a data lake. It's actually like an ocean of data. And there are people who are coming to poach just like they're going to come steal the fish. And most people think they can stop that on their own. Like, I will stand in front of Google and put my hand up and they won't get my data. And that's just totally wrong. But 86% of people think that they can erase their footprints. Completely wrong. So anybody know what this is? Like any of these categories? If you worked in healthcare, you might recognize some of them. Basically, if you touch anything in healthcare, especially in the United States or Europe, you're leaving a huge trail of data. And there's really no way for you to get rid of it. In fact, there might not be a way for you to fix it to make it accurate if they make mistakes. So it's really a massive problem we're facing. So big data is really, NSA is perhaps the most popular example. If you touch any one of these services, they're collecting information about you. So how are you going to possibly go after every one of the services and get that privacy? So these are problems regulators are looking at. And here's what Google looks like when you click on one of their links. This is a sort of click trail. For example, the exhaust you create when you click on one link that is related to Google. So as Google brings more and more data analysts and Intel analysts, they're watching your every move. So I like to put it in terms of real-world examples again. So here's what it looks like in Chicago. They're generating 1.5 billion gallons a day of wastewater. They're doing analysis of it, big data analysis, to find environmental risks. One interesting fact, for example, is the fish might die in the water, but there's no unregulated substance. So everything's clean according to the data. But the analysis of the environment shows that there's something not right. And this is a classic example of how we build laws around things that are very sort of politicized. But data science shows us the shark, or it shows us the fish, or it's basically it shows us the threats again. So you might be looking for diseases, you might be looking for drugs. And in fact, that's what's become very popular lately. That's what people have been doing. So this is a doctor saying, we can find the person taking the drug by block in Chicago. So for example, if you take a prescription drug and they look in the water and find it's a non-prescription drug, they'll say, your prescription's on file, but you're taking something else according to your wastewater. Or there's a huge amount of OxyContin, or there's a lot of cocaine in the wastewater, so there's something bad going on. And this is a map of the world now that's being generated that shows you where the drugs are in which city. So it's surprising to me, but Italy smokes the most pot, Croatia does the most heroin, London's ecstasy, which I guess is expected. But cocaine use is so high in Britain that their entire water supply has become contaminated by cocaine. So the idea of generating all of this knowledge, right, to dip in and to basically find the sharks actually creates the situation where you can't hide. If you're a shark or if you're a fish, it's like, where do you go to get away from all of this? And in the 60s, this was talked about quite a bit. So Hal, for example, in the movie, right, 2001, was this perfect engine, it was a perfect robot, and he was supposed to be able to keep the crew alive. That was his job, was to make the mission successful, and instead he ends up killing all of the crew. So there's a warning from 1968. Blade Runner is also from 1968. The original book was written around that time. Same thing. You send robots off to do things, what do? They come back and try to kill you. This guy wrote about world memory, and he said, if you auto-transcribe everything in the world, if you build a big data environment, again, this is 1968, so this is when the first mainframe really became a mainframe and started the whole computer revolution. So they predicted back then that if you do auto-transcription, big data, build a Google, you end up killing everybody, murder. So Can't we draw a simple rule? Can't we just say to people, hey, there are two things here that we can do. We can either like make it really helpful or we can make it really creepy. And we would like it to be helpful, and if it's not helpful, just stop doing it. The problem is, philosophically, it's really, really hard to build that line. And so we need better tools in order to help us create that line. And the story I always tell here is when I went to China multiple times for work, the first time I went, I had my laptop with me all the time. If I sat on the toilet, I had my laptop. If I took a shower, laptop in the hand outside the shower, soap with one hand. So the second, third, fourth time, I started to get a little more, it's like riding a motorcycle, really. The first time, white knuckle, hands on the thing, I'm going to die, I'm going to die. Second, third, fourth time, I'm just like, I'm sitting back. I'm like, this is amazing. I'm going to ride without hands. I'm going to stand on the seat. So as I started to build confidence, I realized some of the cool things. So in China, for example, they would open my bag, take my cables out, wrap them into nice little bows, and put them back in the bag. Kind of creepy, but also kind of nice. You ever try to straighten out your USB cables? Huge pain. And just for perspective, this just happened in the hotel here. They took my USB cables and straightened them out for me. So when I came back to my room, I was like, cool, it's not just a Chinese thing. Galaxy. Galaxy? Yeah. So unless there's someone following me around, actually breaking into my hotel room and straightening my cables out, which is really creepy, but I still find it convenient. So they also did laundry for me, which who knows what they do with my laundry. Put RFID tags in. I mean, you can get really crazy and paranoid about it, but ultimately you like your laundry being folded. In China, they folded my dirty laundry, which I thought was creepy. But they folded everything. Perhaps they couldn't tell it was dirty, but to me it was. So the point is here that we have a scale that we can use. So instead of saying black and white, creepy, or cool, we can actually say, how are we assessing threats, and is it sort of a reasonable threat assessment method? So binary is like black hat, white hat. So you're bad, you're good. And obviously that gets a lot of false positives. So it was a huge error margin. And then we start to rank it. So if you're working for Mandiant, you just say, is it from China? Well, then it's bad. And so you have these sorts of things, these triggers that make you think something is worse than it is. It's an ogre, so it's worse than a human. And then we go to meaning, which is like building a heat map. So Fahrenheit, Celsius, it basically moves you up and down the scale where you can say, for example, when it's hot out, it's good, but of course for some people hot is bad, so it just depends where you are. And then finally you move to 0 point, which is like an absolute scale, like Kelvin, which is like if we do this, we run out of money. So that's kind of the best area to be in. If you're actually going to do big data analysis, if you're going to look for threats, you should be in a 0 point scale. But it's really hard to do that because you can't really tie all of the risks to some financial impact. But that's where we're trying to go. And the reason you don't get to exact, you actually find sharks, well, you do sometimes. Like I used to do this in investigations. I'm a really big fan of attribution to the person. I've been talking about that for years. And so I'm really happy that we're getting closer to that now, legally and publicly. But the more you do exact analysis, the more intelligence you have to do that exact analysis, the less fish are actually swimming around. They just give up, basically. There's an old saying, no fish in too clear water. And so in lakes, if the fish can't hide, they can't thrive, they die. They're basically all gone. So you really don't want to go too far to the right. It's like the old capability maturity model. You end up spending so much money for robotics or for automation that the company goes out of business. What's the point? So you keep it down sort of 0 point meaning scale. And honestly, we're really working with meaning scale stuff now anyway. So those are the two stories. So we've basically covered, right, we've talked about knowledge and how knowledge is formed and why big data knowledge is different. And then we talked about the risk and how risk is different now. So let's talk about controls we're going to use. And this is the fun part of the presentation because this is where I get to say, help. We need better controls. So this is sort of basically how Hadoop maps out if you look at everything going on. It's a distributed file system. It's on top of that is an operating system. So just think of it as a really distributed way of it's like a giant computer, essentially. You've distributed out all the operations, and you distributed out the files, and now you're telling it to do things for you just like a real computer. How many people use Hadoop today? I actually can't see anything, so you could put up your hands or not put up your hands. I wouldn't know the difference. But I like asking questions anyway, so you can feel like you're participating. So the idea here is on the blue side over here, there are some security controls out by themselves. There's some project names here, Nox, Rhino, Sentry, XASEC was just acquired. And so we hope that we can get AAA and CIA out of that. So, right, we want authentication, authorization, we want audit logs, we want confidentiality, integrity, availability. And I like to use again, I've been in the industry 20 years, so I'm kind of stuck in the CIA model, but I think it still works, and I can give you lots of examples. But what I'm finding actually is people are trying to reinvent these models and come up with new acronyms. So Cloudera, for example, will give you the Access Data Perimeter Visibility model, which is crazy to me because perimeters are disappearing. I'm not going to say they're going to go away entirely. I mean, castles didn't go away entirely. We still have castles to look at. But more to the point, the idea of a castle was that you have a room that you can go in when you want to be safe, and you have people to respond, like if there's a threat, which we still do. We're in a room here, we have badges, obviously we have police, so it just becomes less expensive. So the perimeter model to me isn't a good one. XA Secure has policy, audit, access, and encryption, which is just weird. So I think we can do more of a CIA AAA. And here are sort of my assessments of what's going on. If you want to do authentication, you're basically going to try to do that with Kerberos and some tokens, which I'll look at in a second. If you want to do authorization, you're going to do a few ACLs here and there. It's pretty sketchy, right? If you have a way of doing ACLs, you might get it on a few systems. But with audit, you have very scattered logs. Good luck trying to find all of the log data you need. In fact, good luck trying to convince some of the developers to even turn on logs, because they're going to say, wow, that's a performance hit. I'm not sure you want to do that. That'll slow down our ability to find the shark. And you're like, trade-off, right? I want to be able to make sure there's no shark in the system, but my system's trying to catch the shark. So how do I figure that one out? And then confidentiality, good luck with that. So there really isn't a lot of stuff going on. We're getting there slowly. So here's authentication broken down, as I said. You can see that daemons run as a single user. They run as Hadoop, traditionally and typically. And HDFS is a user that has quite a few important processes running under it. And you can see the group Hadoop has these users in it. So basically, if you ran this command at the bottom, anybody know what this command does? You can shout it out because I can't see you. Take a guess. Minus RMR, what might that mean? What about minus RM? Add an R to it? So Hadoop has made it conveniently simple and different. I don't know why they made it different, but RMR is basically remove recursively, and then slash is root. So this is a command, sudo as the user HDFS in the group Hadoop on the file system, delete everything. And because everybody runs sort of as the same process and the same user, you can delete entire. And this happens. Not necessarily this way, but some new data scientists might come on the team and be given a task, and they go in to work on the tables, and they go in, to this huge 96 petabyte array, and they start working on it, and they go, oops, drop the table, and then the entire company shut down while they try to figure out how to restore all of the data, and it takes a week. So they were going, big data is so fast, they were doing processing and analytics that took 7 days, and in their big data environment, they were down to 7 hours. Well, that's awesome, but now they have to restore it, which takes 7 days, so it's actually taking them longer than if they don't have the ability to protect themselves. So this is the reality. This is really what the book's about. The reality of big data is that you have data that's shared, you have networks that are open, you have nodes that are distributed widely. You don't really know where your perimeters are. You can build perimeters, but you want your environment to be really big and really scalable. So every time you build a perimeter, you're shooting yourself in the foot in some sense. The web services tend to be wide open. You can talk to them and do what you want. The access controls tend to be wide open because performance. And clients are almost always unauthenticated. So we do have transactional integrity concerns, of course. You see Twitter fail sometimes, and you get a whale. Does it really matter? People actually go back to work for a little while, and then Twitter comes back up, and they go back to tweeting. But there are people starting to use Hadoop for really serious stuff, like balance sheets. And when that happens, you can go to jail. If you screw up the balance sheet, the transactional errors, and you need to have an audit log. So as we move into the real environment, we need to think about real environment risks. So here's a lesson from my past. I was working with a group. I wasn't working on this project, but I was working with the group that was building the rockets and some of the stuff in the rockets. And so in 1996, they launched Ariane 5, and it blew up. And it destroyed everything. So the lesson there was you have one chance to get this right. Don't screw it up. When you launch it, it better be safe. And when you look at it that way, you think, okay, software should be assumed to be faulty. I point this out because a lot of people say, new DevOps environment, agile, we should think about software as faulty, we should live in this. And actually, this is really old thinking. So there's a lot of examples. I just happen to be involved with this one personally. So I saw the guys' faces when they lost everything. Their PhDs were gone, basically. All the research was destroyed. So you don't want to live through that. And you don't want some mission-critical equipment to die just because of some stupid software error. Ariane 5 was blown up because of a software error that didn't even matter. Right? It was a big mistake. But the more I thought about it, the more I realized we're not launching rockets. It's not like it's going out into space and we have no way of talking to it. In fact, the Internet of Things is even more like this. We're constantly attached to it. It's everywhere. We can talk to it as much as we want. It's much more like a healthcare model where we're trying to get rid of malaria. So it's always around us and we're always testing it. And so in 2012, I presented at RSA conference how we should look at the breach data, we should look at the risk in these big environments the same way that they looked in the 1800s at cholera. And so this just so happened that I was watching, I was actually working in a financial company, and I was watching some of the stuff people were doing, and it was all big quant analysis, big data analysis. This was a while ago now. And they had this book out by, what's the guy, Tufte. And so I was reading Tufte, and I went through the book, and sure enough, he had all these examples. One of them was Jon Snow. And then I went and looked at all the network stuff, security stuff, and I could not find any reference at all to cholera, which I thought was really weird because it's such a powerful example. So I did a whole breach presentation about how we could change the way that we do network analysis. And since then, I have seen people develop algorithms that actually can do exactly what Snow did, which is figure out that if there's a contaminated water source, which would be like your source of could be command and control, it could be a virus that's propagating, you could figure that out, it can stop it because the nodes can actually say that's the bad thing and they can block it. So usually when we enable action in an environment, like a business environment, people get really, really mad because we have so many false positives, because we're doing it like the binary scale, black-white. If we can do it over in the knowledge scale where the intelligence is so good that we can actually realistically, the same way Dr. Jon Snow did, figure out the source of germs, then it gets better. So anyway, to cut a long story short, basically, we need to do systematic treatment of illness. And so when people say treat these environments like cows, not pets, that's an analogy like people like to use, which basically means you should just shoot those servers dead when they're sick. So if you find a server and you think something's wrong with it, just kill it on the spot. That was their analogy. And I did a bunch of research into livestock. I grew up around livestock. And I realized that's not at all how people treat cows. They're actually very valuable. So what they do instead is they come up with a system that has easy, routine, and minimum judgment solutions, kind of like taking aspirin. If you have a headache, it's very easy. It takes very simple treatment. So you can easily identify your headache, you can treat it with some aspirin, and it takes minimum judgment to decide what to do. So the only way you can make that work is if you have on the right hand this IKEA model, which goes back to big data. So basically you're identifying who is sick very quickly, you're keeping records of everything that's going on, you're evaluating them daily to make sure that you're staying on top of why the sickness is caused, and then you're adapting until you see improvement. So if you do that, you can develop aspirin. And so this is the model that fits better for big data. And we have very few of these so far. So there are a lot of signs of Hadoop illness. I could go on for a long time, but I'm running out of time. So I'll just give you the basics here. Kerberos isn't the best thing. It's not working very well, and it's probably not very secure the way it's been implemented in big data. We have a lot of job tickets and delegation, which seem pretty insecure. We have data node authorities, which don't have ACLs. We have lack of multi-tenancy awareness, which is obviously a problem. It's like, who likes DOS? That's pretty scary. And so you can do lots of bad things in these environments. Very quickly, you basically run your environment as cows, if you will. So you basically delegate out all of these jobs. So all of your cows become your assets. They're doing all of the work. They're eating the grass, and they're producing themselves as assets, I suppose, if you take the analogy. And so, anybody seen Blade Runner? You get this weird situation where in order for the cows to be successful, maybe you allow some of them to delegate to other cows. And so in the actual security model of Hadoop, you might come in as a client with Kerberos, okay, everything is safe, but then you give one of those job trackers the ability to delegate another job. So you get a spawn job that sort of runs off on its own, which is essentially the story of Blade Runner. So the spawn job goes and runs off, but then it decides it wants to stay alive forever, and you have to kill that job. And I've actually seen this, where data scientists are going into the Hadoop environment like Blade Runner, and they're being like, kill that job, and kill that job. It's taking too much performance, and that one's taking too much performance. And why is that one still running? It's supposed to stop after 24 hours. And so you get this weird environment where they try to stay alive as long as possible. So if I move quickly through the environment, I can find lots of cows, right? So there are lots of places we should be looking for illness. Very few of them we're actually tracking very carefully right now. And if we keep adequate records, we build a system like this, which has sort of a taxonomy, right? It's our knowledge learning system. So we start to very quickly figure out, as we evaluate the systems, where we should respond, where the most threats to big data are. So for example, in a typical environment, you might have 30,000 nodes, one person managing the whole thing. And if a system dies like this, it can take the entire environment down. If the name node dies, it can take the environment down. If too many data nodes die, it can take the environment down. So you want to fix that. You do something like this. You take the name node, which is sitting off on its own here on the right, and you actually just sort of replace it with an actual enterprise-like stack. And then you make the network really, really fast. And so if the network is fast enough, then your redundancy is back to the way it was before. You're not relying on all of these individual little pieces staying alive, and there's no downtime. So you can go further with this, and you can start to assign, anybody know what laughs is? Besides laughing, which no one's doing. But if you have laughs, least authority file system, I found very few people have heard about this. It basically says, I will give you the least authority to these files by assigning you a key. So if you want to look at work files, you can look at that, but you can't look at home files. So imagine the power of a system like a big data system that's supposed to protect your home life, but it's supposed to allow analysis of your work life. You can actually make that happen now, simply through cryptographic tools. But you can only do it if you have the ability to assign it to an actual data store. So another way of looking at this is using a cumulo, which is a little technical here, but the bottom line is you can actually assign classification, which would be work home, top secret, private. But the only way this works if you classify data is if you actually then allow people to only have access to data that they have classification rights to. So you can see how these tools need to be built. They're sort of there already. This came out in 2006, was modified by the NSA. It didn't work very well for them, obviously. Somebody was able to take data they weren't supposed to. But they still released it as a cumulo, and you can jump on Apache and help out with it. So sort of in summary, what you see is you start to look at your environment differently. You have clients, you have network, you have operating environments, you have communication between the operating environment, and you can build controls into each one of these. And it starts to look a lot more like the enterprise and a lot less scary like this new crazy distributed world of 10 billion devices that you don't know what to do with. You break it down by what they're doing, you assign authority, and you classify data, and it all starts to make sense again. It's using these old models and applying them in this new environment, and so it actually becomes quite manageable. Although we don't have the tools yet, we're building them. That's how we're probably going to do it. So trusted Hadoop looks something like this. You become multi-tenancy aware. You put ACLs on file systems once you sort of collect your data. You use Kerberos authentication, which is not very good, I have to admit. Randomness is one of the issues we have in Kerberos authentication. Nobody seems to talk about it yet, but I think it's going to become an issue. And you build resilience up, so obviously you don't lose your data. So that's basically it. That's how you protect big data at scale. You use some of these old models and you apply them into these new, cool future technologies. And hopefully some of those stories will resonate with you and you'll go around thinking about whether or not your USB cable should be wrapped up. That's good or a bad thing. All right, thank you.